Good morning students. In previous lecture, we have completed chapter number 4, that is current, electricity and magnetism. In today's lecture, we are going to start beginning with the new chapter, that is inside the atom. It is chapter number 5. In previous standard, you have studied about what is atom, what is molecule and what are the main constituents of the element. So now in this chapter we are going to study more about atom and we are going to explore atom in detail. So let's start with this chapter. First we will see what we are going to see in this chapter of inside the atom. The atom is very well known structure for every particle. So today's topic is types of substances, Dalton's atomic theory, Thomson's plum-pudding model of atom and Rutherford's nuclear model of atom. So first we will understand what is the atom. We have seen that the matter is made of molecules and molecules are formed from the atoms. So effectively, an atom is the smallest unit of matter. It is the smallest part of the element which retains its chemical identity. It can be shown by two examples. First, in the left hand side, two atoms of hydrogen, one atom of oxygen gives molecule of H2O, of water. Again in the right hand side, two atoms of oxygen gives O2 molecule. Now anything that has mass and volume is a matter which is called as dravya. Atoms and molecules are the part of matter. An atom is the smallest part of the matter. It cannot be divided further. Now we will see the classification of matter. Matter is classified in pure substance, in mixture. Pure substances are elements and compound and mixtures are homogeneous mixture and heterogeneous mixture. So element and compound and homogeneous and heterogeneous mixture have shown by the figure you can see on your screen. In elements they are scattered differently, but in compound they combine together. Now let us understand the concept of molecule. H2O molecule. Any molecule is made up of different types of atom. So two atoms of hydrogen and one atom of oxygen gives you H2O molecule. Again, two atoms of oxygen shown by the double bond O gives you O2 molecule and here gives you H2O molecule. These are the example. Here we can see the difference between compound and element. So let us understand this by the types of substances from your chapter number 5, page number 28. The chart is given. You have to copy this chart in your notebook. Let us first see the example of water. The formula is H2O. We have to identify whether it is an atom or molecule. It is not an atom. Why? Because there is combining of two atoms of hydrogen and one atom of oxygen. Combining gives you molecule. So it is a molecule. So I have ticked in a place of molecule. Whether it is a single type of atom in the molecule? No, because different types of atoms in the molecule are present, that is of hydrogen and oxygen. It is element or compound? It is not an element, it is a compound. So I have ticked at the place of compound. Let us consider the next. Oxygen formula is O2. It is a molecule. It is not an atom because two atoms of the oxygens are there, so gives you a molecule of oxygen. It is a single type of atom because only one atom is involving and it is an element. Third example is of helium. It is an atom because single atom is present. If more than one atom are present, then we can say that it is a molecule. And it is a single type of atom. It is an element. Consider the fourth example. Formula is H2. H2 for the hydrogen. Hydrogen is an atom or it is a molecule? It is a molecule. So, we will tick in the place of a molecule. Whether it is a single type of atom? Yes, it is a single type of atom. So, we will tick in the place of single type of atom. Different type of atom in the molecule remains as it is, no tick mark. Whether it is an element or compound, it is a element because only single atom is present. That's why it is not a compound. In this way, you have to solve the rest of the example. If we consider ammonia, NH3, it is a molecule and different types of atoms in the molecules are involved because nitrogen and hydrogen, these two elements are involving. So now we have to identify whether it is element or compound. It is a compound because two elements are involving. So now for the rest of the substances, that is nitrogen, methane, argon, neon and chlorine, you have to identify and complete this chart. We can see for nitrogen, nitrogen is molecule, only single type of atom and it is an element that we will show by a tick. Please copy this chart in your notebook. Also, you have to write the first 3 points that displayed on your screen about atoms and element and matter. Now, let us understand Dalton's atomic theory. What is Dalton's atomic theory? It is a British scientist, John Dalton, put forth in 1803 AD his celebrated atomic theory that we are going to understand. And according to this theory, matter is made of atoms and atoms are indivisible and indestructible. All atoms of an element are alike while different elements have different atom with different mass. See, we can consider an example of bundi laddu. Press both these spheres with your palm. What did you find? Come on, tell me. A bundi laddu is found to have an internal structure. It is formed by sticking smaller particles, the bundis, to each other. However, the solid ball, broadly speaking, does not have any internal structure. The atoms are described by Dalton turns out to be a hard. According to Dalton's atomic theory, the mass is distributed uniformly in an atom. Let us understand the next scientist, that is Thomson's plum pudding model of atom. The plum pudding model of an atom put forth by the Thomson in year 1904 is the first model of atomic structure. According to this model, the positive charge is distributed throughout the atom are negatively charged electrons are embedded in it. The distributed positive charge is balanced by the negative charge on the electrons. Therefore, the atoms becomes electrically neutral. See, you can see by the figure the spherical cloud of positive charge and negatively charged electron. So, Thomson's plum pudding model is shown by the diagram. You have to draw a diagram of all the atomic models, that is Dalton's atomic model, Thomson's plum pudding model in your notebook with a neat labeled diagram. Also, you have to write the statement. Let us understand what is Rutherford's nuclear model of atom in 1911. What is Rutherford's statement for the nuclear model of an atom? What he did, He studied the inside of atom by his celebrated scattering experiment and put forth the nuclear model of the atom in 1911. He took a very thin gold foil and bombarded it with positively charged alpha particles, which is emitted by a radioactive element. He observed the path of alpha particles by means of fluorescent screen around the gold foil. It was expected that alpha particles would get reflected from the gold foil if the positively charged mass were evenly distributed inside the atoms. Unexpectedly, most of the alpha particles went straight through the foil. A smaller number of alpha particles get deflected from the original path through a small angle. A still smaller number of alpha particles get deflected through a larger angle, and surprisingly, one alpha particle out of 20,000 bounces back in the direction opposite to the original path. We can see by the figure showing on your screen. Detecting screen, slit, gold foil and alpha particle emitter we can see easily. The larger number of alpha particles that went straight through the foil indicate there was no obstacle in their path. So it means that there must be mainly an empty space inside the atom in the solid gold foil. The smaller number of alpha particles that get deflected through a small or big angle must have faced an obstacle in their path. It means that the positively charged and heavy part causing obstruction. Rutherford put forth a nuclear model for atom as following. There is a positively charged nucleus at the center of an atom. Almost the entire mass of the atom is concentrated in the nucleus. Negatively charged particles called electrons which are revolve around the nucleus. The total negative charge on all the electron is equal to the positive charge on the nucleus. As the opposite charges are balanced, the atom is electrically neutral. There is an empty space between the revolving electron and the atomic nucleus. So use your brain power. Which discovery did point out that an atom has internal structure? Thomson's atomic model discovered that an atom has internal structure. What is the difference between the solid atom in Dalton's atomic theory and Thomson's atomic model? The Dalton's atomic theory explains atom is a hard sphere, while Thomson's atomic theory explains atom has plum pudding model. Explain the difference between the distribution of positive charge in Thomson's atomic model and Rutherford's atomic model. In Thomson's model, positive charge is distributed, and in Rutherford's model, positive charge is in nucleus. So this is all. What is the point difference between the place of electron in the atomic models of Thomson and Rutherford? In Thomson's model, electrons are embedded in positive charge, while in Rutherford's model, electrons revolve around the nucleus. What is the thing which is present in Rutherford's atomic model and not present in Dalton's and Thomson's atomic models? Rutherford's explain empty space between electrons and nucleus, which is not given by Thomson's and Dalton's atomic model. So in this way we have studied. Thank you.